Next up is VPN, also known as Virtual Private Network. What happens a lot of time is that, especially if you have a very distributed list of devices, so you've got devices all over the world, and you want them to fully communicate with each other, because obviously there's all these things like gateways and routings and NATings and proxies and a lot of stuff in the way and firewalls that limits your ability to connect to a specific device on the other side of the internet. And because if you look at subnets, as I say, they're usually in a certain proximity. They might not be close, but a subnet usually covers a certain area on this earth. This area is the subnet. Okay. Whereas sometimes you want to sort of break that rule, where you want to move a subnet to anywhere in the world, but you create your own subnet. Obviously the word private will tell us it's a private subnet. Net obviously is network, so it's a private subnet. It's actually a virtual private subnet. Do it like that. And the whole idea is to use the actual network infrastructure that already exists and use that as a new sort of mechanism of communication and build another infrastructure on top of that, your own network. But still communicate through the real world. So what it does is it uses the packet inside packet principle. So it actually sends a packet inside another packet. So in this packet, the payload will be a whole other packet that they actually put into the payload. So that means you can actually send a packet from here to there, but then it actually carries on and does something else. And then when it comes back, it gets back to the original point, gets packaged again, the packet inside packet, gets retransmitted back to here. I strip the outside packet off and I can resend it somewhere else. But the applications behind those connections doesn't know what's really happening. They're still just sending a normal packet, the other side gets packet. They have no idea that all this magic and smoke and mirrors that actually takes place in between. They think it's a normal network. Okay. So, and the virtual private network, like I said, because it's a packet in packet, it actually acts as the payload. So it goes up to here basically, and everything there just sort of forwards it, copies it, and basically wraps another packet around it, and then it sends it somewhere else. So in order to do that, the VPN still needs a server. Or obviously if it's a very busy, high-load VPN, you can have multiple servers. And what happens then is that you've got a central server, and a lot of people then, what we call clients, connect to this VPN server. And as soon as they're connected, these clients then get virtual interfaces. So many interfaces we covered here. They get a new virtual interface, which act as if they have an extra network card with a new IP. And applications can then talk to that IP and that network card as if it's a new subnet. But what actually happens when you talk to that virtual interface, it just wraps another packet around it and sends it via the actual interface. Does it make sense? Okay, it sends it to the VPN server. The VPN server will then, all traffic in VPNs always goes through the VPN server. So all servers, so it gets to the VPN server then says, oh, where must this packet go? Oh, it must go there, sends it there. The other application then gets it via its actual interface, the real network card. It gets unwrapped, then it gets given to the virtual network card. The virtual network card then receives the packet, which is not actually, it's sort of all smoke and mirrors, as I said. But the cool thing with that is now that you bypass all the other mechanisms in place. Because you have all these rules. There's rules like, first of all, there's routing rules. Okay, you've got all this routing rules that everything needs to know about the other side. You've got subnets behind public subnets, or private subnets behind public subnets that you can't access. There's firewalls blocking certain ports, certain protocols. Okay. Oh well, this name is technically IP ports. Okay. there's all these restrictions. So what we do with a typical VPN setup is the outer packet goes on the outside. That packet is something that already works. It conforms to all these limitations because the client always connects to the server. So there's already a route, there's already a socket. So that means information can jump both ways. It uses one port number, so the firewall won't block it. But now, because that packet goes through, we can put any payload on it. So we can send any sockets, any IPs, any type of connections, anything. We've got freedom. But we can only send to, obviously, devices on the same virtual private network. So that's the whole point of a virtual private network, is to remove all those barriers and form your own network. But obviously what we also do is it does actually have a certain measure of security, so that people can't just connect to your network and do anything to your PCs. It's usually like it uses full SSL encryption or TLS or whatever, and it's got certificates and all that stuff you can set up. But yeah, and obviously because it's got these two layers of packets, it's got an underlying protocol, which is the packet on the outside, which is run on the real live network, the actual network, not the virtual network. That is your underlying protocol. So most VPN, obviously, you can either function on TCP or UDP. Each has their advantages, each has their disadvantages if you run on those. Especially if you start, if you mix them up. If you send UDP payloads, but the underlying protocol is actually TCP, then the response isn't like an actual UDP. Because now your UDP starts functioning like a TCP connection. Because your packets will have certain delivery and the sequence will be right. So technically it's not UDP anymore. That's because you're sending a UDP packet inside a TCP packet. Okay. So the reverse is also true. Where you send, if you send TCP information or TCP payload, but your underlying protocol is UDP, now what will happen is that the error checking is not going to happen between two nodes. And once it's sharp, it'll go to the next two. Now the error checking is going to be the full path. So it will work, and it might actually be faster. But if there is a faulty network, it's going to be a lot slower. Because it's going to have to go through the whole path to discover that there's a problem. It needs to send it all the way back to say, no, retransmit this back, and we're going to go all the way back there. You see, so you need to choose sort of what you want to do and how it is going to work. Our VPN at the moment is running UDP as an underlying protocol, and all the other traffic runs on top of it. So yeah, I just found that for speed, especially because we're pushing voice through it, which is UDP on UDP, which is actually fine, which is not a problem. It actually works quite well. So yeah, our TCP connections, obviously, like I say, if there is a network issue, it's going to be slower. But if the network's fine, there's no wires that are faulty or anything, you're actually going to get a bit of a speed bump if you put TCP inside a UDP packet. Okay, so here's just a typical sketch. Let's go through the sketch. I've basically drawn a VPN server, it sits there. If you look at this list of items here, the red ones is private subnets, so they obviously have IPs in the ranges, in these ranges, because they're private subnets. And the black ones are public subnets, so they'll obviously have IPs that are not in these ranges, so they're internet IPs. And in the middle there's all these gateway servers. The black connections are obviously public connections, and the red connections will be private connections. So what I've just explained here is that you get a client there, and there's obviously a VPN server. So the client does a normal connection to the server. This is a normal, straightforward connection. It's nothing special. It's as if you're opening a normal socket through the internet. So it can send and receive data. But now, inside that socket, or that tunnel, it actually sends other packets. It's completely packaged. It's gone through all these layers as the payload. When the server gets it, it can say, cool, okay, now I need to send this packet to that client. But that client has already connected. It's already got the connection established. So that pipe's already open. So now we can actually reach it because it's already connected to the server. Like I said, that established connection's already been made. So that's why now this guy can actually send data to that guy. Even though that guy is behind the subnet, I can initiate a new connection. I can just send a random UDP packet, the first initial packet I can send it will work. Okay, because it's already a mechanism open. So in your subnet, you obviously have a whole new IP range, a whole new subnet you actually create. So I just made an example here. 192.168.20.0, and it's obviously 24-bit mask. So you've got 253 addresses we can use. The reason why it's 253 is because it's actually 256, but we can't use 0, and we've got a gateway, and we've got a broadcast, so it's technically -3. Okay. But yeah, now we've got this whole new subnet. So the result is almost like you have a new subnet, and you can just transmit data from there to there. That's what the applications think is actually happening. I can open a socket there, I can send UDP data there, there's no firewall, there's nothing. I can just send it, it will get there, it will get delivered. Obviously provided that initial connection has been established. The actual raw, actual network connection has been established. Okay. Yeah, obviously your VPN server must have a public IP if you want your VPN to work through the internet, otherwise it's not going to work. Or you can probably do it behind a NAT router if you set up port forwarding. It can also work. So that your clients can reach your server. The only problem then is if you use an ADSL line, ADSL has dynamic IPs. So your router's public IP will constantly change every 24 hours or 3 hours or 4 hours. It actually changes. So then you need something like dynamic DNS to update that IP so that you can resolve it to the new IP. Okay. Okay, the last thing. Okay, obviously, as I said, the devices, the clients, that's the guys on the far edges. They actually have two interfaces. One's the actual network interface, the network card. The other one's a virtual network interface. And each's got a different IP. They will never be in the same subnet. Otherwise, it's not going to work. There will be different subnets. Yeah, then there's a thing that we call exposed subnets. This is where things get really complicated. That's where you have where the client, let's say there's a client there, but he wants to give, let's say, this guy access to another PC in the same subnet. Okay, so now this guy needs to know that if he accesses this range here, he needs to know to send that packet through the VPN and not through the actual network. So now there's a lot of configurations that must take place on a lot of places. And this is what this is all about. If that happens, your subnet, this subnet here, needs to be registered on the VPN server. So the VPN server must know that that subnet exists. Because if it gets a packet, and the IP is like, let's say, it's not this, it's let's say 10.0.0.5. The VPN server needs to know that it needs to forward it to a specific VPN IP so that that guy can forward it to the right PC in its subnet, into its subnet that sits behind it basically. What the server then also does is the server, as soon as a client connects, usually the server will send those subnets as routes to all the connecting clients. Because this client needs to know that if somebody wants to access this IP, which is 10.0.0.5, it needs to know that it also needs to send it through the VPN and not through the actual interface. So what happens is as soon as they connect, as soon as that first connection, the actual original VPN connection is made, the server actually sends back and says, oh, you need to add these routes, and sends the list of routes so that that guy can access it, obviously, and know that those subnets are actually on the VPN, non-public domain. The last one, this is a very important one as well. Your client, this is where a lot of people also mess up. The subnet on the client route needs to be configured. So this guy here, that's not on the VPN itself, he needs to know how to reach this guy again. That's why I said about the reverse route you need to configure. And when we talked about routing here, it's okay if you let the packet go one way, but it still needs to know the reverse. Because if this guy receives the packet from 10.0.5, the 10.0.0.5, it's going to reply to 10.0.0.5. But what it's going to do is it's going to look at its routing table and send it to the gateway. And the gateway is going to try finding it on the internet. That's not going to find it. So your connection will just run dead. But it is actually working, it's not getting back. So then you need to tell that guy if you need to set up a new route there for the 10.0.0.0 network and set that guy as its gateway. So that when it does reply, it actually sends it, this is a red pen, it actually sends it to that guy so that the packet can all go all the way back. And that's also what we've done with our network here. What we've done is we've actually made that server is also the gateway server. So you don't need to configure those routes. The gateway server just takes care of that. Because the gateway server is the VPN client. So it automatically knows, oh, sends it by this network or this one or this one. Okay. And you'll see, lots of the root commands. If you want to add routes, you can, like I said, you can always also use that one. It's root add -net, specify a network, space net mask space GW for your gateway and your gateway. You can add routes. Only problem is if you reboot, it loses those routes. So you need to put them somewhere to save it, depending on the operating system. In Windows, actually I don't know where to add them in Windows. In Nine actually you can just put them in your rc.local file, or actually in your network interfaces file. I know there's a way you can add routes there as well. Okay. I think that covers VPNs. Does it make a bit more sense? I know this is, like I said, things get a little bit hazy, where it gets a bit complex because now you're building virtual networks, but using existing networks to construct these virtual things. You're still following. Okay, cool.
That was pretty